Here's a real quick example of Newton's second law. And Newton's second law, remember, is the only equation, and it's the net force equals mass times acceleration. Here's a block. It's sitting on some table, and it has a mass of 10 kilograms. I pull on it in the right-hand direction with 8 newtons, and newtons are the unit for force named for Sir Isaac Newton, and someone else pulls to the left with 3 newtons. So what is the net force that acts on the object? It would be 8 minus 3, which equals 5 newtons to the right. And so 5 is the net force equals the mass, which is 10, times the acceleration. So the block will accelerate to the right because this force dominates this one. And we divide both sides by 10, and we get A is 1/2 meter per second squared. So this object will accelerate, and I can plug this directly into the big 4. Because now I know, let's say that it's at rest, and I say that I want to know, and I say that I move it for a distance of 12 meters. So now I know the acceleration, the distance, and the initial velocity. I know my 3 unknowns in the big 4. I can solve for the other 2. Suppose I want to know how long it takes. Well, I know that I have my 4. I can use any one of them, but I want to try to keep in mind that I know acceleration, distance, and initial velocity. So the final velocity squared equals the initial velocity squared plus 2 times the acceleration times distance. The initial velocity is 0, that term goes away, and the final velocity squared is 2 times 1/2 times the distance that I move it, which was 12 meters. So the final velocity is the square root of 12, which is going to be can't simplify, I guess I can simplify it to 2 root 3. Root 3 is about 1 3/4, something like that. It's 1.73, so it's 1 3/4. So it's 2 times 7/4, and that's about equal to 3.5 meters per second. So I get a speed equal to about 3.5 meters per second. We don't have to be exact because we're not allowed to use a calculator on the exam, and we're not going to see answers like 3.5, 3.6, 3.7. You're going to see answers like 1, 3.8, 9, or can't tell. So we know that 3.5 is in the neighborhood, so we found our answer. So estimation often is every bit as good as having a calculator. In fact, often it's faster because we don't have to type numbers in. We can just estimate things. So I remind you, it's a good idea to kind of know that the square root of 3 is roughly 1.73, and the square root of 2 is about 1.41. So those are good things to keep in mind when you're working problems. But here we see a typical application of the net force equaling mass times acceleration, a use of Newton's second law.